We have had speakers come and join us from a number of different organizations, but this is the one I'm most excited about. Jason is joining us, who is the editor-in-chief of the MIT Technology Review. And he, in addition to being the editor-in-chief of the MIT Technology Review, has contributed over his career to journals such as Red Herring, where he was also the editor, Acumen Journal as well, and has been a contributor to New York Times, The Economist, Financial Times, and Wired. So we gave you a view into the near future. He's going to give us a view into the much further future. So please help me welcome Jason. Jason, thank you for being here today. Really appreciate it.
It's a pleasure.
Hand this to you here.
It's the end of the day, and I am the last thing between you and drinks. So I'm just going to chat for a little while. I swear to God, just 20 minutes. And then I'm going to sit up here and I'm going to ask any questions you have. We can have a talk about the future of technology. I'm going to talk about a few of the breakthrough technologies of 2017. Since 2001, we have selected what we think are the most important technologies in the world that we think are going to have a really big commercial impact. And the question that you are all thinking is, how do we do it? I don't know. We slaughter goats and look at their entrails. We read tea leaves. We make it up. No, we have unparalleled access to an extraordinary group of innovators and inventors, both within academia and working in research at companies like Salesforce. And then, to be candid, the little trick is we follow the money. Honest to God, we just see where the majority of research funding is going, what venture capitalists are dragging out of startups and universities, and where the new companies are being commercialized. You're wondering what our track record is, how good we are at it. Well, the good news in being a journalist is I can always say that when it looks like we're wrong, we're just interestingly right. So in 2001, that's a guy's name is Stephen Quake. He invented a technology called microfluidics. This is now a $40 billion industry. It does pretty much what it sounds like. It manipulates liquids at very small scales. What's interesting about this is that this is now used in every clinic and laboratory in the world when you have your genes sequenced, and therefore, in a way, it's actually a bigger industry than $40 billion suggests. We believed in this for so long when there was absolutely no commercial application at all. We kept on telling people this was a really cool thing, even though no one was actually using it. And the first business application was interesting because it suggests how really novel technologies can have revolutionary applications. The first person to ever use microfluidics in a commercial space was a guy called George Whitesides at Harvard. And he found that he could print a little gene array on a piece of blotting paper. And using that, you could detect a cellular catastrophe like AIDS or malaria. And that turned out to be important because it created a cheap private diagnostic tool in really poor parts of the world where healthcare workers were often illiterate and people wanted privacy. So you could find out if you had a disease, and then you, in a little village in India, and then you could go to the big city and be treated with it. And these little pieces of blotting paper microfluidics cost a couple of cents. Now, the big machines that Illumina uses are now, they're $10 million machines. But that was a technology we found first. Here's one that you all use. That guy is Adam Chaya. He invented Siri, the first broadly used personal assistant. When we found it in 2009, it was a research project inside the government's Silicon Valley Research Center, SRI, which is why it's called Siri. They initially developed this for the CIA and for the Army. The idea was that individual soldiers, what the military calls the dismount, would be able to communicate in natural language using Siri. And though the Army didn't buy it, Steve Jobs was walking around SRI, saw it and said, that's a pretty cool technology. So we got that right. I got this really badly wrong. This is stupid. This was an idea we had in 2010, which was that TV, broadcast TV, would become social. We honestly thought that social media and broadcast TV would kind of merge in some inexplicable way, and all of television would become like American Idol, and you would be interacting in real time. And the last thing in the world the large broadcasters wanted to do was give up part of their business model to Twitter and Facebook. And so we were completely wrong about that. But remember what I said about being interestingly right? We do nowadays tend to go and watch TV using social media. We just have our damn laptops or iPads or iPhones open in front of us, and then we comment along to our friends about presidential debates in real time. So as I said, even when we're wrong, we're actually completely right. So I'm going to take you through the 10 technologies for 2017. That's our art director's feet right there, sticking out from behind. I'm going to begin with an important technology called reinforcement learning. It's an artificial intelligence application that many of you will be using in Salesforce's own product, Einstein, in the not-too-distant future. I'm only going to do 4 technologies today because I want them all to be really related to the enterprise. Who knows what deep learning is? Okay, a few of you do. So I need to explain what deep learning is really quickly, and then I'll explain why you care about reinforcement learning. For as long as I've been covering technology, artificial intelligence was in this deep winter. Artificial intelligence actually predates computers. The guy who essentially created the first computer, Alan Turing, devised the first theoretical framework for artificial intelligence. And yet, until around 2010, we made no progress at all with AI. In 2010, a bunch of people from the University of Toronto, working under a guy called Jeff Hinton, found that if you programmed computers to learn loosely like our brains learn, they could begin to perceive huge patterns really quickly. And if you threw an enormous amount of data at a problem set and ran that data on the same chips that we use in our gaming systems, GPUs, you could very quickly begin to do really intelligent tasks like recognize cats in Google videos, or scan a check and get the handwriting correctly so you could go and deposit it, or win a game of chess. The problem with deep learning is it has to use enormous amounts of data, what they call training sets, and you have to have really powerful computers. The other problem with deep learning, this will surprise you, is that every single piece of data in a deep learning set needs to be humanly tagged. So these companies, Salesforce, OpenAI, Google, Mobileye, are all combining deep learning with this new technology, reinforcement learning, which is really powerful because it's much more efficient. Human beings don't have to tag all the data. And here's the really creepy thing. The artificial intelligence systems can begin to teach themselves. They don't need human beings to tell them what to learn. So why it matters? If AI is to begin to make real progress, it needs to be self-directed. And the business applications are fairly broad. Mobileye, which is the self-driving car company in Israel, which was just acquired by Intel for $15 billion, is using reinforcement learning in order to make cars who can operate in a much larger set of environments than the Google self-driving car. We're going to talk about a real business application that everyone in the room will be using fairly shortly, called Conversational Interfaces, but we can use them for a variety of other applications as well. Reinforcement learning in combination with deep learning is the booster rocket that will push AI into broad commercial use, and not in 2 years or 3 years, but right away. At the end of the talk, I want to talk to you a little bit about some of the unintended consequences of this, because the combination of these technologies, deep learning with reinforcement learning and some other strategies, are going to impact the jobs of almost everyone in the world. And whole forms of labor that we've become used to are going to be eliminated very quickly. So here's my second IT-based big breakthrough of the year: practical quantum computers. Now, a bunch of companies are working on this. Microsoft has 2 projects, one at the University of Delft, another which they're running at the University of Santa Barbara in California. IBM, of course, has its cognitive computing effort with Watson, and is, in an extraordinary act of generosity, has made freely available to every developer, including the folks in the room, what they call the quantum experience, where anyone can learn how to program on a quantum system. But Intel and Google, they all have large practical, commercial quantum computing efforts in use at the moment. There's even a startup called D-Wave in Vancouver that is selling practical quantum computers for $2 or $3 million each at its list price. So why does it matter? Well, there are categories of problems which cannot be solved with all the time in the universe using a conventional computer. This is what computer scientists call polynomial time. And many of those are quite simple problems that we would like to be able to solve. Now, there's a big debate in the quantum computing world about whether some of the problems, like the traveling salesman problem, the most efficient route between 2 spaces, could be calculated by a quantum computer. But the business applications of quantum computing for the folks in the room will be very real and very immediate. For a start, every single existing cryptological secure system could be broken almost instantaneously by a quantum computer. And you could additionally create a whole new kind of cryptography that could not be broken. But there are some forms of practical problems which aren't these obscure problems that we know we'd want to go solve using quantum computing. For a start, quantum computers could model quantum reality. So you could use them to investigate any possible molecular combination. You could create new drugs, create new batteries. This essentially puts into the hands of ordinary businesses the ability to do supercomputing in real time, and even to attack a whole bunch of applications we couldn't otherwise solve. It's really interesting stuff. I wanted to go and give one practical application of an AI application that you'll all be using very simply. Conversational interfaces are the idea that when we can talk to our computers in real time, they can talk back to us intelligently and give us practical suggestions for what we might do. We're used to using these conversational applications in very narrow settings. At the moment, we can talk to Siri and we can ask for the directions. We can ask Google Maps how to get to a place. Amazon has its Echo. Google has its home device. But at the moment, the dependability of those conversational interfaces is fairly limited. What we really want are conversational interfaces that can be surprised by us and learn in real time. And that's where reinforcement learning comes in. The big company working on this at the moment is Baidu, but our hosts for the evening, Salesforce, want to go and give you this conversational interface as well inside App Builder and inside the CRM technologies they're serving to you. The idea is that wherever you are, rather than having to type into a computer or even worse, tap your way across a flat screen, we should be able to talk to computers in the language that we use most naturally all the time, which are our own voices. This sounds like a really simple thing to do, but it's actually one of the most intractably hard problems in computing. We have extremely high expectations when we talk to each other, and we have all these social cues. As I look at you, you're looking at me, you're nodding, or you're looking bored, and I kind of know what you're thinking, right? We infer from human beings all sorts of things from chatting with them. At the same time, we have a whole theory of mind when we talk to each other, and we have this deep embodied set of data about how we expect the world to work. Computers really have none of those things, but a networked set of computers operating in the cloud with access to all the information in the world that could learn in real time using things like deep learning, begins to put into the hands of ordinary enterprise players the possibility of creating natural interfaces where your users won't really know whether or not they're speaking to a person or to an intelligent system. So why it matters? I think this is the future of computing as information becomes embedded in the ordinary things of life. It particularly matters in countries like China, where it's very difficult to use a keyboard or an interface to go and interact with a computer. But I think the business impact is to make information as invisible and ubiquitous as electricity is now. I think it makes AI into a common resource. I want to end with one last IT technology for the evening. This is an innovation inside the financial technology space, fintech. Blockchain is the underlying digital ledger that is used by Bitcoin. So Bitcoin is kind of crazy as a cryptocurrency. It's beloved by cyber libertarians on the West Coast because they feel it is a currency that is not controlled by any one government. But economists like me think that money tends to have two properties. It's a medium of exchange, and it is a store of value. And as such, Bitcoin isn't a particularly good currency. For a start, it's heavily speculated on all the time. So its value goes up or down 10, 12% over the course of the month. That's not a very good currency. But underlying Bitcoin is a digital ledger called blockchain. And there are a variety of other blockchains in use as well. A whole bunch of very serious organizations like IBM, like the Bank of England, are exploring what an invisible, transparent, and utterly trustworthy ledger that counted every single moment in a transaction, who paid for what, when, and how, would be a permanent record going forward of every single transaction. And when you begin to do that, it begins to do strange and interesting things. It begins to bring transparency to markets where they hadn't existed before. And I'll just give a couple of examples of some real business impact. IBM is moving its entire worldwide supply chain, which is huge and enormous and involves millions of different parts, to blockchain. Walmart wanted to import pork from China, but was worried about the health safety of pork products from China. So now they actually track everything that happens to a pig from the moment it leaves a farm and is slaughtered and arrives in the United States, which is a pretty extraordinary thing to be able to do. It'll surprise you to hear that there's never been a futures market, a derivatives market for diamonds. We don't really know where diamonds come from. There's meant to be a provenance for them, but essentially when you get a diamond, you're getting it on trust. Using blockchain, you can track at every single moment what happened to a stone after it left a mine in South Africa and arrived at Tiffany's, which is a pretty interesting thing to do in terms of creating a full market around diamonds. And one of the most interesting applications for me is around the use of medical health records. So the Health and Human Services department in this country has been trying to go and get doctors and healthcare providers to commit to a nationwide electronic healthcare records without success for the last 20 years, essentially, because there were all these weird, perverse incentives that encouraged everyone not to share data. Using blockchain, we can know exactly what happened to a medical record as it follows a patient throughout their entire life, from birth to their final sickness. So blockchain is an incredibly powerful technology. Like many really revolutionary technologies, though, the truth is that I can't tell you today what types of applications blockchain will create. But I think it's going to be the internet of money. Let me leave you on a final thought. No one is as big an optimist about new technologies as I am. I believe that new technologies can solve big problems and expand human possibilities and grow wealth. But technology isn't an absolute good. And many of the technologies that I've shown you tonight have potentially negative consequences. Unless, tech-literate people, like the folks in the room, and ordinary citizens really ask themselves what you want to use these technologies for, rather than be used by them. During the Industrial Revolution, we destroyed millions of jobs all over the world over the space of 3 generations. In 1850, around 80% of Americans worked on farms. And by the beginning of the First World War, that was down to a little more than 10%. And today, less than 4% of Americans work on farms. A whole way of life vanished. But at least we did the Industrial Revolution over a few generations. The disruptions forced by AI are going to be very sudden and very quick. And all sorts of ways of being and types of employment are going to vanish overnight. Consider doctors. So we have trained doctors to do a kind of piss-poor form of pattern recognition. And we've relieved them from the whole burden of being care providers in many senses. We've outsourced care provision to nurses and doctor's assistants. You see your doctor often for a very short period of time, and he basically does a kind of little better than chance form of diagnosis and then prescription. AI systems will be much better at diagnosis than doctors will be. So Watson, at least with pathology scans of lung cancer, has an accuracy rate of around 97% for identifying different forms of lung cancer. 97%, nearly perfect. A human pathologist, after 30 years of training, she might have a 70%, 65% accuracy level. So these changes are going to be pushed through society really quickly because of economic imperatives. Hospitals and insurers will insist that people begin to augment themselves with AI systems just to reduce liability. Let me go and give a really immediate example of a job that's going to vanish almost overnight. In the United States at the moment, in most states, the single largest employer is, believe it or not, driving semi-trucks. Driving trucks, right? It is also the last job, pretty much, that a man or a woman with a high school education can still command a good 6-figure income. There is a company in Silicon Valley called Otto, recently acquired by Uber, that has self-driving semi-trucks on the road right now. One recently drove between, I think, Denver and Detroit or something, absolutely flawlessly. So at least initially, those big Otto trucks are going to move into the marketplace because the truck drivers will want to use them because they will allow them to go and operate longer hours. But very quickly, they'll begin to suppress wages. And shortly after that, I suspect we'll see more and more trucks on the road with no drivers at all. And that's going to happen to a lot of industries. God forbid it might even happen to some of the programmers in the room. These big societal changes are manageable. They are essentially policy decisions that we can make about how we want to manage a universal basic income or an earned income tax credit or retraining or education. But we need to be conscious about the technologies we use. Each one of the technologies I showed you tonight has enormous potential to enrich us all and allow us to do exciting new things. But they're also kind of scary because at the same time, they're really powerful. And we don't quite know what they're going to do. So on that note, I will fall silent, and I'll answer a few questions if you have any. And then we can go and have a drink. Yes?
So you talked about self-driving cars, and
Should we get let's get a mic, so because we're recording. So who you are and where you're from as well, which I think people.
My name's Jody. I work for Hunter Street Corps here downtown. Hi, Jody, Hunter Street Corps. When you talk about things like self-driving cars, there's a lot of ethical issues already there. The debate about if they have to choose between hitting pedestrians or other people on the road. I mean, the burden responsibility is removed when you have this sort of automation. So too, when you talk about deep learning, like what is the framework and the basis for the ethics behind what is considered learning? So
let me talk about some of the ethical problems around self-driving cars, and it's going to terrify the people in the room. The decision that the automotive industry has come to, and then I'll talk about ethics and AI, which is a really interesting debate at the moment. So in philosophy, there's a category of problems called trolley problems. Has anyone heard of trolley problems? So trolley problems are called so because they ask you to imagine what you would do if you perceived a trolley about to run over 4 helpless people. Would you pull a lever that would push the trolley onto a sidetrack that would run over 1 person? So would you sacrifice 4 people for 1 person? So we're going to have to build AI systems that will be able to make those kinds of moral choices. When is it appropriate to run over a dog in order to not hit people? We make those moral choices all the time as human beings. But here's what's weird. Human moral intuitions are really flexible, and they're conditional, and they're situational. And also, they vary by culture. Right? People are varied. There's no common set of moral intuitions. So the AI industry, at least in the case of self-driving cars, has been having to build into their cars an ability to do trolley problems. Here's the bad, terrifying news. They decided that when it came down to it, they would always save the driver. I mean, of course they would, right? Because the driver bought the damn car. So Daimler-Benz and all the car companies said, we have to make a choice, and in the end, we want to go and protect the person who spent $100,000 on our car. I think that's a bad way to approach it. But the better news is that the AI industry is having a really serious conversation now about the ethical use of AI. It's a huge debate. The most public form of it is the question about whether or not we want to summon the demon, in Elon Musk's phrase. So Elon Musk is worrying that we're going to build these systems that are going to be smarter than we are, and they're going to take us over and either make us into pets or kill us altogether. And I think that's the dumb form of the debate. The interesting form of the debate is, do we want to manage and think through how jobs are going to be eliminated? Do we want to think through really basic things like the bias that might be implicit in an AI system? So these deep learning systems are powerfully predictive of human behavior. They are really accurate about whether or not someone is, for instance, a good insurance risk. But that might tend to institutionalize and perpetuate racial or ethnic biases we have in society. And maybe we don't want to go and do that. I don't know about that, but what is really important is that folks who care about this, like you, involve yourself in the debate, and you write into guys like Eric Horvitz, who's the head of research at AI at Microsoft, who's funded what he calls the 100-year study in AI to address these very issues, which is how we want to go and use probably the most powerful technology we've ever created in human history. For the first time, we're building machines that are smarter than us at some level, and machines that we don't fully understand, which is weird and new in the world. Other questions? Please.
So I'm interested in the truck driver question, and then I have another one after that. There's something like 11 million jobs, middle-class jobs, that would be eliminated once those autonomous trucks come on the road. Yeah. And I'm curious what the sociologists and the economists are thinking. What will happen to those 11 million people, and what will be like the political and social consequences of that many jobs disappearing in the middle class so quickly? And then secondly, related to that, I've wondered, looking at these things, so I was involved in telemedicine a little bit, and I saw some of the conundrums surrounding regulatory environments and these types of technologies, and I'm wondering, are there people that think that maybe potentially democracy is at risk here because it moves so slowly? Yeah. The regulatory changes move so slowly. Will it be able to adjust to these technologies quick enough to make the right decisions?
Those are great questions, and people are really worried about the future of democracy. I am. I suspect, and you're an educated, smart group of people, I suspect who thinks that the principal reason for wage stagnation in this country is trade? Raise your hand. I see you're smart people. Who thinks it's technological unemployment? That's the right answer. So economists can actually fairly accurately grade the hierarchy of what's called the great decoupling, the separation of wages from productivity growth. There has essentially been no real wage growth in the United States for 40 years, adjusted for inflation. Almost all the returns in productivity have returned not to the 1%, but the top 2, 3, 4%. And the reasons are, first, technological unemployment, two, the tax policies coming out of the Reagan and Thatcher era, three, something which is hardly talked about, which is it's a brand new thing in industrialized countries, is geographic immobility. We move less often than our grandparents and great-grandparents did. And the fourth reason, way down there, is what we fought the last damn election about, trade. So to your question, we are about to have a gigantic disruption socially and economically. And I think the last election in the United States, Brexit in Great Britain, the apparent rising polls of Marine Le Pen in France, I don't think those were really elections about immigrants or all the things that we talked about. I think that these elections have been kind of rebellions against modernity. I think they are protests by people who have been left behind. And I think so far, the people who have been left behind have largely been the white working classes in the industrialized nations. But I think what's about to happen next is about to go and rise to touch almost everyone except a handful of people in very privileged positions. So if there was a chance that we could not debate these issues and talk about the policy reactions we want to have, I think that's passing. We're going to have to honestly go and confront the society that we're building. Because you can't put technologies back in the box. They're going to be made. And the question is, how do we want to use them? Any other questions? I'm Mr. Happy-go-lucky guy tonight, aren't I? You know.
We can do one more.
So my name is Eleanor, and I'm with Ergotron. And I'm not a technologist. I actually am kind of the customer of my technology group. And so I came to look for inspiration, for business process inspiration, to feel more intelligent than I do on a normal day-to-day basis because I can use certain keywords in our conversations. But I'm also the mother of 4 children, 2 in college, so yes, I'm broke. And my question to you is, when we talk about progression and we talk about all these pieces that you've discussed, if you were standing in front of a group of current college students who have technical aptitude and interest and are embracing these technologies and excited about the technologies, what would your advice be?
That's a really good question, and I will attempt to be inspiring and really optimistic. I've got kids too. I've got a 2-year-old girl called Ada, who was born on the birthday of Ada Lovelace, who was the first computer programmer. She was a woman. And she wrote the first programs for a computer that was never built in the 19th century. The difference engine was a mechanical computer. I've got an 8-year-old boy called Alonzo, who's really good at mathematics. Really good. Much better than I ever was. He really understands intuitive operations. And I worry about their future too. And Alonzo, kind of asked me the same question, because he hears me, talking about these things and thinking about them. And he asks how he should prepare for the future. And we don't know what the jobs of the future are going to be. But we do know that they're probably going to involve basic fundamental skills. So if I was advising college-age kids, I would say, don't worry too much about vocational training right now, because a lot of the job that you think you're going to do in 5 years is probably different from the job that you're training for now. Instead, in a phrase we often use at MIT, give yourself these skills so that you can learn how to learn. Learn how to learn. So learn the basics of mathematics, and don't just learn it by rote. Understand the actual intuitive backing to it, so you really understand how it works. Learn some languages. Learn critical thinking. Learn one computer language. It almost doesn't matter which, just so you can understand how computers think. I mean, you want to choose something, Python is a good, but learn something. Learn these basic tools about how to think about the world. And then, I went to one of those very old-fashioned English schools. Learn some history. Learn some philosophy. Read some novels and some poems as well. There's a phrase that's not very popular anymore. People talk about a liberal arts education. And the phrase has nothing to do with politics. It comes from the Latin, libertas, a free man, literally. And the Romans believed that a free man knew how to think, knew how to learn, and that there was no situation you could put a free person in where they couldn't learn. So I would tell your college-age kids not to worry too much about getting the education that guarantees a job right out of college, but think of themselves as people who are likely going to be alive for 120 years. Who knows? We're going to live a lot longer, and we're going to live a lot longer in a healthy way. So they might change their jobs 4 or 5 times over the course of their career. And that's a frightening thing maybe for people my age, but your kids are going to actually enjoy that, because it's going to be a future of exploration and possibility where you don't just do one thing. Let me end by saying I'm the world's biggest optimist about this stuff. Technologies aren't an absolute good, but they can do amazing things. And we face big problems, but those are also amazing opportunities. And all of you are serving customers and companies and building products that want to be innovative. And you need to stay on top of these technologies so you can bring them to the marketplace and innovate in your own way. And on this note, I will thank Salesforce for being such a great host.